Whiteboard animation A to Z. O-level math complete course part 3. Okay. Matrix, vector in 2 dimensions, and transformation. These are the 3 topics that we are going to cover in this video. And this is part 3. Timeline is in the description. Ask me or anything on the comment section. Good topic, matrix. Okay, so what is a metric? A metric represents another way of writing information. It is an array of numbers. Okay, this is another way of writing information. It is an array of numbers. Each of the numbers in the metric is called an element. A size of a metric is denoted by number of columns multiplied by number of rows. Okay, so this is column multiplied by rows. Addition of matrices. Just look carefully. This is how you make an addition. Sounds great? Okay, this is how you do the addition, and the same thing you do the subtraction. Okay, it's really easy concept. Just see it carefully, the animation stuff. Okay, multiplying matrices by a scalar quantity. We multiply it to a scalar quantity and the numbers increases. Each elements inside a matrix, it increases, multiplying to all of them. Okay, multiplying a matrix by another matrix. The condition is that this one must be same. Rows and column must be same. And just see how you do the multiplication as well. Okay, note that if matrix A is multiplied by matrix B, then this is not the same as matrix B multiplied by matrix A. Yeah, the order really matters. Reversing the order of the multiplication does not give the same result. However, there are some exceptions to this. This is a different thing. What is I? Identity matrix. In a real number system, 1 is a multiplication identity such that A multiplied 1 is equal to 1 multiplied A is equal to A. The same thing is identity matrix. Identity matrix is just like 1. For matrix, the identity matrix I is also multiplicative identity such that, yeah, and it has different order. Matrix A is multiplying by identity matrix. You can just think this as multiplying a number by 1. It will give the same thing, and changing the order will give the same thing. Okay, so I is nothing but 1. In a matrix world, we can just denote it as I. It has different matrix order. Okay, it could have one multiplied by 1 order, which means one row and 1 column. It could have 2 multiplied by 2 order. It could have 3 multiplied by 3 order. So any matrix which have the same order of, for example, 5 3 2 1, and if we multiply this by an identity matrix of order 2 multiplied by 2, then it will give the same thing. It will give the same 5 3 2 1 if it is multiplied by 1 0 0 1. So identity matrix is nothing but 1. Okay, just like I told you, it's nothing but 1. Determinant of a matrix. Determinant is just a special number that can be calculated from a square matrix. It can only be, for now you need to understand how to calculate from a square matrix. Okay, just see how it is. Multiplying opposite numbers and doing subtraction. The inverse of a matrix will, if A is multiplied the inverse of A, it will give identity matrix. How to find the inverse matrix? See it carefully. In order to find the inverse matrix, first of all, what you're going to do is taking the determinant of A, and it's easy. In order to take the determinant of A, you need to multiply by multiply to opposite number. A multiplied by D minus C multiplied by B. Okay, A multiplied by D minus A multiplied by D minus C multiplied by B. Okay, then in this way you will find the determinant, and after finding the determinant you multiply, and then you try to you change places of A and D, and you change the sign of C and B. Okay, at start it was like this, A B C D. Okay, but first of all we're going to change the places of A and D. So D will be here, A will be here, and then we are going to change the sign of B and C. So for example, if it is positive, both of them are positive, then it will be negative. Okay, if it was positive and negative, then it will be negative and positive. Okay, if it was negative and positive, then it will be positive and negative. Okay, so the sign will change. After doing all that, then you're going to do all of this calculation, and then you will find the identity matrix. Okay, determinant of matrix A. Okay, we have been given this matrix, and now we need to find the inverse of this matrix A. So let me just do it in front of you. So first of all, I'm going to find the determinant of A. So it's going to be 2 multiplied by 4 bracket minus 1 multiplied by 3. Okay, now I'm going to so it's going to be 11. Okay, the determinant will be 11, and after finding the determinant, we're going to do this, give this order. So 4 will come here and 2 will come here because they will change position, and then the sign will change it will be +1 instead of -1, and it will be -3 instead of +3. Okay, we have done it. Multiplying this by the by this, and then we're going to do the multiplication, multiplying this 1 upon 11 to each element inside a matrix. So if you try to multiply it, each one, so 4 multiplied by 1 upon 11, -3 multiplied by 1 upon 11, 1 upon 11, 2 upon 11. Okay, and if you do that, here you go, you find the inverse of A. And if you try to multiply A by the inverse of A, then it will give I. It will give the identity matrix. Okay, as you can see here for yourself. There you go, it's completed. The topic matrix has been completed, and now we are going to move forward for vector and then transformation. So let's begin. Dimensions of vector has two things: magnitude, direction. Okay, we have this graph and A to B to denote. Okay, so let's say that we have 2 points A and B, and we can A to B, we can denote this in 3 ways. Let's say that we have the point A to B, and we can denote this as in 3 ways, either using this A to B, or putting this magnitude of A to B A, or giving the coordinates. Okay, giving the coordinates in this way, x and y. So this is y, and this is x, and this is A. Okay, yeah. Magnitude of a vector can be found by Pythagoras theorem, and it's going to be here. This is the magnitude of A and AB. The direction, it is a direction vector, but if anything start from the origin, it will be known as the position vector, OP. The magnitude and direction can be written as a column vector. This is a column vector. This is how you write the column vector, and you can also use a column vector as translating, and translate the triangle ABC by this. Another thing you need to understand is, okay, so it says the question says that translate the triangle ABC by this column vector, but you need to understand one thing here, that you need to see the sign. Okay, let's say it says -5 on the x-axis, so it's saying that we need to go left. Okay, we need to go left, -5, and if it had said that we need to go +5, then it will go right on the x-axis. If it had said that we need to go, 6 value has been given in the y coordinate, so it's saying that we need to go up because it is positive 6, which means we need to go up 6 times, and -6, which means we need to go down 6 times. So it's the same thing here, that we have this A and A, B, C, and so A need to go left 5 times, 1, 2, 3, 4, 5, and it needs to go 6 times upward because it is positive, so 1, 2, 3, 4, 5, 6. Same thing applies for B, 5 times going left and 6 times going up. Same thing applies for C, 5 times going left, 6 times going up. It depends on the plus and minus, it depends on the sign. Okay, this is how you translate the points. Okay, yeah, it will go like this. So you need to understand the direction. Absolutely correct. Multiplying a vector by a scalar. If we try multiply a scalar which is greater than 1, then it will enlarge, and if we try to multiply by a scalar which is less than 1, then it will decrease. Okay, k is a constant. Also find out that what is the ratio between the two column vectors. Okay, let's say that we have the point CD and we have the point AB. What is the ratio between these two? So knowing the ratio, we can use the constant k, and then make equal to each one, x-axis and y-axis. So 4 is equals to k2 and 2 is equals to k1, and then if you try to do the division, the calculation, then we will get the value 2. We'll get the value 2. So AB, the vector AB is 2 times than CD. Okay, in order CD to be as large as AB, then it needs to be multiplied by 2 in order to look like AB vector. Same thing. Addition of vectors, point to head and point to head, and then head to head. Okay, you need to see this, how the division works. But if we move to opposite, then sign will change. Yeah, that's also correct. Now we have been given the questions. Okay, so the question is, in a triangle ABC is equals to AB is equals to P, AC is equals to Q, and D is the midpoint of PC. So this is the midpoint. Write these vectors in terms of P and Q, starting with BC. BC, what is BC? This is PC. It's going from here. This is the direction. And if you try to find the vector BC, then we all know what is the rule of the addition of vectors. B, right? First break this in B and C, and now we need to find what should be in between. and it must be same. Okay, so I could go from here BA and then AC. Okay, so BA I could write, okay, so it could work BA plus AC. You can see that both A are same. So BA, going from BA, which means the value of AB is P, but since we are now going in reverse direction BA, so the magnitude P would be negative. So minus P plus, and AC is in the same direction as we wanted to, so and its magnitude is Q, so Q. This is the value of BC, the vector BC. Okay, this one is done. Now we need to find BD. Since we know that D is the midpoint of BC, so BD is equal to 1 upon 2 BC. Okay, so minus P plus Q, and there you go, this is the answer. BD is done. Now what remains is AD. Okay, how to find AD? We can find AD by AB plus BD. We have found BD, the value of BD, and we also know the value of AB. AB is P, positive. It is in the same direction as we wanted to, and plus BD. BD, the value of BD is 1 upon 2 minus P plus Q. And yeah, and the answer would be 1 upon 2 P plus 1 upon 2 Q. And this is the answer. Okay, well done. Vector, the topic vector is completed. And now we are going to the next topic and the last topic, which is transformation. So let's begin. Okay, transformation. When a shape is transformed, the original shape is called the object and the new shape is called the image. Get the picture? A translation is given by the vector 5 minus 6, which means each point will go 5 on the right and minus 6 down, as we have done previously in vector. Translation is one of the way of transforming an object. Reflection is also one of the ways. Reflections are carried out in mirror lines. In a reflection, corresponding objects are the same distance from the mirror line, but on the opposite side. The object and the image are congruent, but the image is reversed. One thing for you guys to note, for you to notice, that there are two things: the mirror lines and the object. We got two things: the mirror and the object. So we got the object and we got the mirror line. So now we need to make a reflection. Just like we look at the mirror, we try, it gives us a reflection. The same thing here is in here, the reflection. Okay, so we can just find out so easily that this point will come here, this point will come here, this point, okay, counting the boxes, always count the boxes, will come here. This point 1 2 3 1 2 3 will come here. Now you can see it's becoming an image, and there you go. This is the image, this is the object. The same thing as I did. Okay, reflection is done, translation is done, and also we need to understand the metrics of reflection. We also need to remember the metrics of each one. So what it's saying here is, okay, you need to see here as well. If for example A and B, one, okay, so A is in here, A and B is in here, and the column vector of A is 1 and 0, and the column of vector of B is 0 and 1. And if you try to make a reflection on the y-axis, then the A will have a reflection in here, so it's going to be, the column vector will be minus 1 0. And if you try to make a reflection on the x-axis, then the reflection of B will be here, and the column vector will be 0 and minus 1. Okay, there's a difference. So this is the matrix, and see here as well. Now it's time for rotation. In a rotation, you turn an object about a point. The point is called the center of rotation. You got two things: the center of rotation and the object. To rotate a shape, you need to know the angle of rotation, direction of rotation, clockwise or anti-clockwise, and the center of rotation, where it is, and you need to find it. Okay. Rotate this shape to 70 degree anti-clockwise about 0. Okay, so let's see the animation. And you should see this carefully. Just see it carefully. How to rotate this. And there you go. Object P has come. This is how you rotate it. This is the image. And we need to remember or just understand the matrix of rotation. And also try to see this animation as well. This is really important. Describe fully the single transformation that map flag A and onto flag B. Okay, this looks like a rotation, and now we need to find the center of rotation. Remember, the distance is same from the pivot for the two objects. Pivot means the center of rotation. We need to know the distance. Okay, this is how you see the distance, which means this is the center of rotation. The pivot has been found. This is how you need to do this. Okay, the way I'm I'm letting you see the animation. This is how you need to remember it. Now enlargement has come. In an enlargement of a shape, the image is the same shape as the object, but it is larger or smaller. The object and image are not congruent because they are different sizes, but they are similar. Okay, just see the animation. The animation will do the good. The animation will do the stuff for you. See the animation. Okay, enlarge this shape by scale factor 2 with the origin as the center of enlargement. Now we do enlarge this shape by a scale factor of 1/2 with the origin as the center of enlargement. We will decrease this actually. Enlarge the triangle A with scale factor -2 and center at the origin. Okay, this is how you do it. Combine transformation using matrices. This is a little bit challenging. In order to find any matrix transformation, center must be the origin, and as for reflection, the mirror line must pass through the origin. In order to find any matrix transformation. Question: M is a reflection in the y-axis. E is an enlargement scale factor 2 center at the origin. Find the single matrix which represents M followed by E. Then transform each of the points. We can do this in two ways. For the first way is doing this graphically. First of all, doing an enlargement with the scale factor 2 center at the origin. Okay, so I'm going to do that. Points. Okay, so we have these 3 points. And so we have this enlargement. We have found it. Okay, this is enlargement, and now we need to do reflection on the y-axis. So doing the reflection, the points will be right here. Okay, we have done the enlargement and reflection. We can do this in this way, or we can do this the other way as well by multiplying the matrix of the enlargement and the reflection, and then using that combined matrix to multiply with the column vector of each points. So let's start with what is the matrix of enlargement? -1 0 and 0 1. Okay, so 2 multiplied by 2, 2 multiplied by 2, so it again is going to be in square form. So it's going to be -2 0 0 and 2. Okay, we got this combined matrix, and then we can use this to multiplying each of the coordinates, each of the column vector of the points. Okay, the column vector of Q is 2 and 1. The column vector of P is, the column vector of R is, okay, so multiplying each one with the column vector of the points. So 2 multiplied by 2, 2 multiplied by 1. -2, 2. Okay, so converting the point P, the column vector of the point P, and you got this new one. So it's going to be right here. Okay, then -2 0 0 2 multiplying by 2 1, and we will have -2. We will have 4 -4 and 1. So -4 and 1, we will get 2. So -4 and 2 will be here, and okay, so -2 and 6 here. So there you go, we have found it, the image. This is how you do it. Okay, we can do this graphically, or we can just do the calculation by ourselves by using the matrix of both reflection and enlargement. Okay, and thank you so much for watching. This is the end of O-level Maths course part 3, and now I'm going to move to complete the course SAT course, and there are so many topics which are not covered in O-level maths, but because I'm doing SAT course, that's why I decided to merge it. Some of the topics in O-level maths will be covered in SAT course, SAT maths level 1. Okay, so yeah, that's it. Thank you so much for watching, and I hope I'll see you guys in the next future videos, in the next future course. Goodbye.